I'm going to talk about computational sociality. This is an important thing, a new way to organize people inspired by machine computers, biologic computers, neuron brain computers, society computers. It's a subcomponent, a tiny subcomponent, one of maybe 180 subcomponents under some more general theory, which is called general empiric computation. We know 5 types of computational system. We know machine computers, we know societies, we know brains, we know minds, tools outside of brains that make brains able to be powerful and smart, um, and we know biological computers and information systems like DNA and ribosomes and protein and all that stuff. So we know 5 kinds of computational system, and they inspire each other. And the new devices, new algorithms, new computational systems that we notice in biology or in machines or in societies or in brains or in minds cause us to invent new machine forms of computation and algorithm, which in turn, when they're implemented, inspire us to notice further information system types in biological, brain, neuronal, society, and mind systems. So these 5 kinds of information computer system interact, inspire each other, and they generate constantly through a dialogue new forms. Everything we invent in machine form, or now we're beginning to invent actual biologic computers with biologic substrates, inspire new things we notice in social computers. Every new social arrangement of people that's inspired by computational systems in biology or in neurons or in machines, in turn causes us to notice new things in biologic systems or proteins or societies or machines or brains or minds. So all of that dialogue among 5 computational system types, one tiny, 1/180th of it, is the computational sociality. Now what's that? That's using people in computer-like ways as if the people were computers. It's taking algorithms of how we get processors and memories and sensors and arrays to interact in machine computation and putting humans in analogous roles in relation to each other. And the thing about it is you do end up with better ways to use humans than we've had so far and more effective arrangements of work. This corresponds to something else totally different called the missing micro level of organization. And young people notice this, but old people forget it because they get trained into it and become unconscious about it. But young people, when they're growing up, especially in the top colleges, notice that at the group of 20 to 30 people to 50 people, at the unit of 30 to 50 people and above, the world is highly organized. But at the level of below 20 people, the world is chaos. So the way we hold meetings and discussions is garbage, random, spaghetti, chaos, junk. It's the most frustrating part of our lives. It also occupies the most of our lives. This is a very monastic insight in terms of the monastic model of innovation because the leverage is so great. The leverage is so great. If you manage to multiply meeting and discussion productivity by a factor of 8, say 800% or 8,000%, then on the larger level of 20 to 50, which is combinations of teams, or higher level than that, 200 combinations of teams, or higher than that, combinations of companies, you would have immense results and immense impact. And so it's very attractive when you find that there's really a missing micro level of organization, that meetings are understructured, discussions are understructured, rather chaotic, and people hate them because they're wastes of time. And almost nobody is as productive in meetings or discussions as they are working alone. That's why brainstorming is so ineffective, because people generating on their own and then separately later comparing lists will generate more and better variety than people in a brainstorm performing in front of each other, where they focus too early on what is the first idea that's popular with some faction in the brainstorm room, and several other known, replicated for 50 years research results on faults in brainstorming. So we have a series of insights from general empiric computation, these 5 computational system types dialoguing, 1/180th of which is they generated computational sociality, which is using people as if they're computers. And then what does that consist of? And then that fits into a need we have for micro levels of organization that are missing at the foundation of all the structures of our society, so that everything's based on meetings and discussions, and they are not structured, and they are chaotic and messy and sloppy, 8,000 years old, and bad interfaces. Now, all those 3 insights can go together to do social cellular automata to replace brainstorming, do stratified responding to replace discussions, do scientific rules of order to replace ordinary meeting processes. And this is my 5 basic interfaces that I'm talking about changing, that all of my life have been based on since I changed those interfaces for me 45 years ago when I was an MIT undergraduate, wrote a book on it my sophomore year called Structural Cognition. So I replaced meetings with scientific rules of order. I replaced discussions of stratified responding. I replaced classes and work processes with mass workshop events. I replaced brainstorming with social design automata. And I replaced prose text with fractal page forms. And this is a monastic approach to innovation. It multiplies creativity and productivity of groups typically by 8,800% and more on average. And computational sociality is just one little tiny result of this. But it's an extremely interesting and powerful result. And it's interesting on so many levels. First of all, it's enormously more productive than usual meetings and discussions. But other than that, it's a different way for people to interact. Instead of hearing each other's ideas and then ignoring them and going back to why your idea is better, it actually forces you to use the partial thinking of other people as inputs to your thinking and building on their ideas. This is something we do not voluntarily and easily do. And being put into a social format where that everyone is doing that is breathtaking, because you use other people's ideas. You have to understand and get into them and stop bitching about and secretly thinking how yours is better, and find the virtue in their approach and use it, because you're going to be judged on how good your use was. Whether you got value from the inputs given to you, not whether you liked the inputs or thought they were wonderful. So computational sociality is extremely powerful, extremely interesting, and located as I just stated.